intro going out. We go live in 45 seconds. That's the page I have to get. My pinched nerve is still like periodically going, I shall send a wave of pain through your body. And I really kind of hate it. It's like going fine, would now like to die. This is
Yeah.
going.
Yeah, my wife's got some back pain right now, and it's just like it just seems so cruel.
Yeah.
Like now you don't even have to
2,
pick
1.
up something.
We're live. Yeah. No, you don't have to pick up anything.
No.
I injured myself with progressive lenses.
Yeah. And so like now it's just like I have no idea what I did. Something I did hurt my back.
Yeah.
And now it hurts.
Yeah. This is our fate now. We have hit that point in time when the presbyopia kicks in, your body's going to hurt for no reason you can identify kicks in, and a whole lot of other things.
Yeah.
Hello, tiny intern. I have no idea, tiny intern. I'm going to look and see what the stream info currently is. Oh, that's just the generic thing that caught everyone's attention. Someone was being humorous.
Oh,
hello, null
wow.
denominator. Hello, Sully
Elon-
Two Cats. What did he
Elon Musk is he's sorting out peace in Ukraine and Russia, and it's going so well on the internet.
Oh God.
Yeah, someone take away his phone.
Yeah.
Come on, man.
He really does need someone to take away his phone.
Yeah. Oh well. Whoops.
I
Okay.
need to adjust the color on you. You are very red.
Am I?
Yeah.
Is that my fault or is that your fault?
It's coming in pretty red, so I'm going to adjust it.
Okay. My lights are set a little bit red, but you know me, I also turn a little bit red, so.
Yeah, I don't know which one this is, but there, I now have you looking less like a salmon.
Okay.
All right, let me see if I can fix. My hair is not green screening well.
Before we get into this,
Yes.
shout out to the folks at ISRO. They're saying goodbye to the Mars orbiter mission.
Oh man.
8 years of solid science on
Yeah.
a really low budget mission. Like just efficient. Every part of that mission was beautiful and efficient, delivered some great photos. They got 8 years of science out of it.
Mm-hmm.
They like if I had to choose two teams that I like the best, like that aren't, I don't know, NASA. I really like JAXA, and I really like ISRO. Both of them are just punching way above their weight in terms of the science that they do, and it's so great just to see how much science they get done. Their expertise is world class, but they're able to bring these missions in. They sort of pick the perfect mission to get the right amount of science. Yeah. They're willing to experiment and push the boundaries of what's possible, and they take risks, which I just love. And and both of them are, and so ISRO says goodbye to mom, but I mean, they just nailed that mission.
Yeah.
So for all the people working at ISRO, good on you.
Yeah, seriously.
Yeah. Okay.
Thank you, AstroWise, for this sub. That's 48 minutes. Sorry, 48 months, not minutes.
48 minutes. You sponsored for 48 minutes. We'll see you back at the end of the hour. You better pay up.
sometimes I just struggle with words more than others.
It just depends on where you stand in your coffee levels.
Yes, and for those of you following along in my adventures of hurting my neck with progressive lenses, I have finally started physical therapy, but that does not mean the pain has gone away yet. So there's a certain amount of there's like a good 30% of my brain that is currently being like, don't move, do not move. If you move, you will hurt. Stop moving. And that 30% is really loud. So, yeah.
Let us begin.
Okay. I am ready to switch to images as needed. I have the names. I do not have my recording software up.
Oh, I don't either. I wasn't ready.
Thank you all for all the subs. Thank you, Ms. Brick Kitten. All of you are amazing humans.
Are we going to have to take sides, YouTube versus Twitch here?
No, we are not. I am simply monitoring Twitch and you are monitoring YouTube.
Yeah. So I'm team YouTube and you're team Twitch.
Now,
Go team YouTube.
I have no favorite
YouTube.
children.
You show those people on Twitch what for and comment and like this video in a way they can't even imagine.
Thank you for all the gifted subs. Thank you.
Oh, we can't gift subs on YouTube.
Yeah.
I mean, we could. I mean, we could set up the support, but we don't want to because then people won't go to our Patreon. So go to Patreon.
Exactly.
But Linda Sadiq, Citizen Gold, Big Panda Bear, Commentary Fairy, Ben Kalo, Ian Farquhar, John Suffill, you know who I'm talking about, Paul Disney, Nicholas B, you people on YouTube, you're heroes.
Yes. All right, so today is episode 657.
656 says my number.
Okay. This is why I verify with you, because I am often wrong.
Yes, I mean, the YouTube says 656.
I'm going to go with that. I'm going to
go with that too. Yeah.
And I'm going to take my watch off so it stops thwacking my wrist for me. All right.
Let me know when you're ready.
I think I'm ready. I'm going to press record on the audio. I'm going to press...
I have also pressed record.
I'm going to press record on the video. We are recording.
Okay. Here we go. Astronomy Cast, episode 656, Smashing Asteroids for Science. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. With me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. We have hit the month of October and all my Halloween decorations are going out and Jupiter is at opposition and these things have nothing to do with each other, but both bring me joy. Have you seen Jupiter?
Oh, of course. Yeah, hard to miss. We got out the binoculars, half the telescope, the seeing part, but not the holding part, which made the whole process worthless. So I need to go and find a tripod and get it all set up. But yeah, it looks amazing. Just in the binoculars, there's the moons, bands across the planet. You can see it in just my astronomical binoculars. It's such a good time. And this is the closest Jupiter has been in 60-ish years, and the closest it's going to be for decades more. If you haven't already, now is the time. And it's going to be this closest event has already happened, but it's a slow moving closest opposition. So if you can, beg, borrow, steal some way to be able to see Jupiter with your own eyeballs. And while you're at it, Saturn is also up in the sky, so you can see both of them. It's a good time to do some amateur astronomy.
Couldn't agree more. And a good 300 millimeter camera lens was actually my friend on this endeavor. So, I went out with one of our community members and we got We got to see Galilean moons. What more
I
could a girl
really
ask
am
for?
I'm going to follow my own advice very soon and buy a 8-inch Dobsonian
Oh
telescope.
yeah, yeah.
Yeah. Yeah. Our skies are so much darker here. They've been clear, but then we've had the weirdest, clearest October I think I've ever experienced. We're breaking temperature records, and it's just been clear every day, all night, and
Dang.
perfect for astronomy. And so I think I will bring it to a close by buying a new telescope. All right, this week we saw the incredible image of Dart smashing into asteroid Dimorphous. Now, beyond avenging the dinosaurs, what can we learn scientifically from this and other asteroid and compact impact missions? We'll talk about it in a second, but it's time for a break. I love to hear you snicker after my
I
intro. So
I don't know what you're
good.
going to say until you say it, and I am a firm believer that thwacking asteroids in the name of the dinosaurs is something that is to be giggled at.
All right, we're back. I should say, and we're back. All right, take that, asteroids, dinosaurs. We got your back. We have avenged you. So, did you watch the DART mission live in real time this last
So
week?
I have the greatest irony. The Planetary Science Institute where I work, we were producing a video with some of our scientists who are part of the DART mission. And instead of getting to watch the impact coverage live, I was frantically video editing the release about how we successfully smacked an asteroid. And
Right.
there's irony in this, but I watched it after the fact, and it was
That's,
absolutely amazing.
that's similar to you going and reporting on a solar eclipse and not being able to see a solar eclipse. But anyway, now it was amazing. The footage from NASA started up about an hour before the actual impact, and it was just this little gray dot in the middle of
Yeah.
the screen. And for the first 45 minutes, it never went beyond a little gray dot. And then suddenly it was a couple of pixels across, and then a few more pixels across. And then in the last 5 minutes or so, the asteroid got a lot bigger. And then in maybe like the last minute, the smaller asteroid separated from the bigger one. You realize you were going right towards the small one, and then the big one drifted past the field of view, and then Dimorphous just got bigger and bigger and bigger, and then it filled the screen, and then you got one last frame that was like a little ribbon of
Stripe.
asteroid at the top, and then red stripe down below, and you knew that was loss of signal. You could see exactly
Yeah.
where it was no longer able to transmit. And I think what made this mission different from other missions that we've seen in the past was this. It really felt like we were experiencing this one in real time. I mean, it was a 45-second delay, which is not long,
No.
but you saw the images stream in at what felt like video rate, which I don't think we've ever seen this before. And this is like, so this is all everybody has ever wanted,
Yes. Yes.
and you delivered it. So this, but more. Again, keep doing this. I'm like, I get it. It's hard to transmit from far away, and it takes a big receiver, and there's science to be done, and so on. But still, you nailed it, literally and figuratively.
What I really enjoyed was that they carried a CubeSat with them, and they like dropped the CubeSat, which popped out and unfurled, and then the CubeSat was there to photograph everything that was happening. But because the CubeSat is so tiny, it's like the worst 1980s dial-up ever experienced. And so all those images that wonderful little CubeSat took are going to take days, weeks, and months to get back to us. And then we have Hera getting there in 2024, which I think all of us are excited about.
So, but the purpose of this episode is the value in smashing asteroids for science. So,
And it's
do
not
you want
just
to
asteroids.
and comets, yeah, and
Yes.
moons and the moon and all kinds of things. So, do you want to start most recently? Or should we start back at the beginning? When has humanity intentionally first tried to smash a solar system object for science?
Well, the first time it was done on purpose And the on purpose is very important. That was with Deep Impact. And Deep Impact had a number of different goals. It was set out to help us understand the structure of comets, the composition of comets, and to smack the bejesus out of one particular comet so that we could differentiate between what are the surface materials and what are the things that may be buried down deeper that we can only see if we dredge with our spacecraft.
Right. Yeah. And so how did the mission work?
So Deep Impact carried with it basically a refrigerator-sized impactor that it placed in front of the comet, and the comet smacked into it. So NASA folks, a few of them really like to correct people and say, we did not attack the asteroid. We simply stood in its path and it attacked us.
Right.
And I love that little fact. And so with the refrigerator-sized impactor set loose, the main body of Deep Impact, which has now gone on to be called Epoxy, it collided with Comet P Temple 1 on July 1st, 2005, and it rendezvoused on July 1st. I have to get this right because it got your Independence Day with the day that it rendezvoused, and it got my Independence Day, July 4th, with the actual impact,
Right.
thus maximizing
my holiday-
the number of holidays destroyed.
Yeah, impacting the Astronomy Cast team. Yeah.
Yes.
Yeah. My holiday, then your holiday. Now, what did they learn?
It was long ago and far away, and I have forgotten that information and must scroll through my notes. One moment, please.
Comets are made of stuff?
Yeah, I know that, but I think that they learned it's... I don't want the movie. About the ratio...
You can't search for Deep Impact without getting
much I do not wish for. Some searches you have to be more careful with than others.
It was a good movie, though.
Yes, it was, compared to its
The
kin
other one.
of the time.
Mm-hmm. I mean,
Not telling me what
generally, they looked at the ice and the dust and the stuff, and they saw that it was made of things and junk.
Yeah, I'm trying to find out specifically what they learned about the composition. This is why we say that all of you get to watch the sausage being made.
So, Deep Impact,
There we go.
researchers now believe the comets may have transported essential compounds to Earth at one time, playing a
Yeah.
pivotal role. So that's the main one, is they
Yeah.
discovered a lot of about the water ice and the organic material and saw them as a source, comets as a source of organic material for Earth.
Yep. All right, so ask me the question again, please.
And what did they discover?
Well, they were primarily looking to see what is the composition of a comet nucleus. And what they found is there's clays, there's carbonates, there's silicates, the stuff of sand, but it was more the consistency of talcum powder. And there were crystalline silicates found as well. And all of this added up to say comets carried to Earth not just water, and that one gets trickstery because the kinds of water atomic ratios they found don't match our planet particularly well, but they found all these other atoms that helped enrich the environment of our world back during the age of, well, a whole lot more comet bombardments than we're experiencing today.
All right, Deep Impact was first. We're going to continue on with other missions, but it's time for another break. And we're back. So what came after Deep Impact?
As near as I can tell, the next big thing was L-Cross in 2009. And the reason I phrase it that way is there were so many things that either didn't mean to reach out and touch an object with violence or touched something very gently. The Near Shoemaker mission back in 2001, even before Deep Impact, demonstrated that we have the capacity to control a spacecraft so that it will touch down lightly on an object within a 1 meter region of what it's hoping to. In this case, it's the asteroid Eros, and they just settled down and sat there for a while. They landed on February 12th, 2001, and we remained in contact with the spacecraft until February 28th.
It had no landing system. It was never intended to land. They just were able to slowly decelerate it until it just gently sat on the surface and, I don't know, rolled over or something.
It's anticipated that it rolled over a bit.
Yeah, they were able to communicate with it. And of course, I mean, there were all of the spent upper stage boosters for the Apollo mission. There were all of the times that the Soviets attempted to land on Mars, their moon missions. Like, there are craters across the solar system that are left by unintentional spacecraft failures.
And it's not just the moon. Mars, the Beagle crash site has actually been useful in this is what a fresh crater looks like.
Schiaparelli as well.
Yes.
The ESA's mission. Like, there's a bunch of these.
Landing on Mars is hard. It's really, really hard. But crashing fuel stages into the moon is something we have kind of continued to do on purpose. The Lunar Reconnaissance Orbiter mission did not fly alone. It was part of a 2-mission launch. And on October 9th, 2009, its companion, L-Cross, followed their second stage empty fuel tank to the moon, where the tank hit first and L-Cross sent back information, died information. And this was when we, for the first time, got to see just how much water is out there underneath the surface of the moon. The surface of the moon can only have water in the eternally shadowed regions, and places that are completely shadowed we can't exactly see. So with L-Cross, it hit and it splashed out a plume of material that wasn't what we had hoped for. It turned out our models of the moon weren't quite what was they weren't as accurate as one would hope, but there was nonetheless enough of a plume that we were able to measure water ice that was liberated from the surface of the moon during this impact event.
That's really cool. All right, we're going to talk about another interesting mission, but it's time for another break. And we're back. All right, we've talked about Deep Impact. We've talked about L-Cross. Are there any others?
So there have been a whole series of things that were sent down onto small bodies, minor planets, with the purpose of just bouncing around. Some of them bounced in ways they did not intend. My favorite of these is the poor little Feely lander that traveled with Rosetta. And it was in storage for so long. It traveled so far. And then it just didn't quite do its job because it was meant to harpoon the asteroid and attach itself to the surface that way. And its harpoon just didn't quite fire correctly. So there was an accidental impact.
The thinking is that it landed, bounced a couple of times, came to rest, fell over, but was operational. And then its batteries ran out, and then that was that. Now,
in addition to the international mission that was Rosetta and Philae, JAXA, with their Hayabusa mission, has been doing some of my absolute favorite, let's fling everything we possibly can. including anti-tank weapons that have been repurposed at the surface of an object. And it all started with Hayabusa 1 at Itokawa, an asteroid that led us to believe that not the entire solar system is made of rubble piles. And when Hayabusa 1 got to Itokawa, it was carrying with it the first of the Minerva series of missions. And these are little flywheel-having robots. They're cylinders. And the idea is that they bounce around looking in high detail at different places on the surface. And they tested all of this out with Hayabusa 1. Hayabusa 1 went and stole a piece of Itokawa. It tried twice. It didn't get as much as it wanted, but it demonstrated that all of this is possible and set things up for the more ominous Hayabusa 2 mission.
Right. That anti-tank weapon armed Hayabusa 2.
Yeah. They referred to it as a small carry-on impactor. We all know that the reality is it was basically an anti-tank weapon flung at an asteroid instead of at a tank, which I approve of, by the way.
Mm-hmm.
And on April 5th, 2019, it attacked. And the idea was the exact same thing that we did with L-Cross, that we did with the original part of Deep Impact. It released materials so that we could see what is beneath the surface. And Hayabusa 2 was at the rubble pile asteroid Ryugu. And it got to allow us to see how craters form within the rubble pile structure. In addition to that, they had a whole series of little flitting, flying,
hopping, jumping. Yeah.
There was a whole series of different things they did, including, again, reaching down, touching down to the surface of the asteroid, grabbing a sample, which has made it back successfully to Earth. This mission was remarkably successful in everything it did. And from there, we also had our own little favorite OSIRIS-REx mission that on October 20th, 2020, during a pandemic, managed to pull off a beautifully successful smash and grab of asteroid samples.
That was a very gentle impact.
No.
In terms of compared to DART. And
this
others.
Is true, but they still shoved the spacecraft like 30 centimeters into the asteroid.
Yeah, apparently if it hadn't fired its retro rockets, it would have sunk into the rubble pile, which is kind of amazing.
Yeah.
So let's talk about DART.
Okay.
What was the purpose of the DART mission?
To see if we can move an asteroid sufficiently that we can see a change in its orbit around its parent body. In this case, the parent body isn't the sun. In this case, we have Dimorphous with Dimorphous going around and around, and depending on how the impact took place, different amounts of momentum would get transferred. The pretty much worst case would be if Dimorphous was hanging out and the spacecraft plowed in and had a fully inelastic collision and became one with Dimorphous. The best possible situation is one where the spacecraft hits the surface of Dimorphous and flings out a vast amount of debris, carving out a crater, and also itself elastically bouncing off. In the case of a fully elastic with shrapnel joining it, in that case you get the greatest transfer of momentum to the main object. And we're still waiting for NASA to release the details on exactly what happened. We know that there was that plume. We don't know if the spacecraft stuck, bounced, or anything else.
So, at this point, it's just no matter what happened, the change in the orbit for Dimorphous is going to be so tiny
Yeah.
that it won't be visible until several weeks or even months of constant observation to detect the slightest difference in the orbital trajectory of Dimorphous. And we're not there yet. So
Yeah.
right now, we don't know how much of a change that it made. But what does that tell us? I mean, if we see a big change, if we see a small change, if we see no change, what does that tell us about this goal of potentially being able to protect Earth from asteroids in the future?
If we see no change, it means that momentum transfer failed and physics is broken. So I'm pretty sure we're going to see some sort of a change.
Well,
Just
we talked about this, that it could punch right through
yeah, yeah.
and right and not change the physics, and maybe
But
it's still out there.
but the plume that came off, the amazing thing about it is if you have a body and part of it flies away, there's going to be, for all of the momentum that goes away in one direction, it's going to have the same amount of momentum transferred to the parent body that's moving forward. So because we saw a plume, we have to see a change in orbit within error bars.
Right.
And so we can fully expect to see something. We just don't know, did its orbit around Didymus change enough that it's like super easy to see, or is it something that's really hard to see? Ideally, we want to see the change over 3 different orbits, but because of where the asteroid is positioned, it's there's large sections of ocean that make it challenging to get 24-hour coverage. This is a target that is good to see from the southern hemisphere, okay to see from the northern hemisphere, but it's pretty low down right now.
So we
Yeah,
really might have to wait for the Hera mission to the
we should
follow-on
know
Hera
before
mission.
then. We should know
Right.
before
But
then.
it'll do the really precise analysis of
Yes.
the orbit and the consistency and look at the impact crater and all of that. Um, but I guess, can we learn about this asteroids in general? Like, are they balls of rubble the way Osiris, the
Yeah,
way
yeah,
Bennu and Ryugu looked, or are they a chunk of rock surrounded by a thin veil of rubble? Will the different
yeah.
outcomes of the orbit tell us which of those models is more correct?
It should help. Um, the only way to get at what is the structure all the way through is to measure the moment of inertia of that moon. And this is where Hera is going to be able to probably do better observations than we're currently doing with the Lycia CubeSat,
Hmm.
and definitely what we're doing here from the surface of the planet Earth. That moment of inertia will tell us, is it the same density all the way through? Is it different densities going through? And what is that difference? It's the difference between spinning a raw egg, a hard-boiled egg, and a soft-boiled egg. All 3 of them will spin differently because of their moment of
I,
inertia.
I like that analogy. Totally
Yeah. I mean,
yeah,
how
when
do
you
you check if
spin
you
those
actually
3,
hard-boiled your egg? You spin it.
you spin it. Yeah. And yeah, I like that a lot. I'm going to use that. I'm going to steal that. Thank
You
you.
are welcome to.
Right on. So, are there any more comet impacting missions planned for the future, or
There are
asteroid impacts?
always people with plans.
Hmm.
There are not currently any we're going to go out and smack something missions that are in the near future, fully funded, and we can count on to actually do their job. But right now, it's really cool to get to see the Deep Impact mission has been repurposed to become the Epoxy mission, which is out there visiting other objects. We're all waiting to see just what does OSIRIS-REx in its new phase do when it gets to Anubis. That is an amazing object. And yeah, it sure looks like Dart discovered another rubble pile out there. So
Yeah,
I'm looking forward
totally.
to seeing Lucy get to her hopefully metallic asteroid and showing us something very different.
I think is one of the asteroids metallic for Lucy's mission?
I thought so.
Huh.
Did
Okay.
I screw that up?
Well, I think you're probably thinking of the other mission that NASA has canceled, but that's fine. Or not canceled, put on review. The Psyche mission.
You're right. You're right. Psyche was
Yeah.
going to a metal asteroid. Let me correct
Yeah.
that.
Yeah.
Sorry, Rich. Sorry, Allie. And now my dogs are barking. Eddie has thoughts.
Mm.
They're singular thoughts. He has 3 brain cells. And they bark about every 3 to 5 seconds, apparently. There's a periodicity. There he goes. Eddie! All right, that may have worked. All right, at some point we will finish the soundproofing in this room, I promise. All right, so So the Lucy mission is hopefully going to show us other examples of asteroids that hopefully aren't rubble piles. I look forward to seeing more Itokawas, slightly rubbly
Yeah.
cashews. We need more of those in our lives.
Yeah. Yeah. We need to go to all. We need to go to all the asteroids and
Yeah.
smash a bunch of them and find out what they're made of. All right. Thank you, Pamela.
Thank you, Fraser. And thank you so much to all of our patrons out there who are supporting us through patreon.com. If you would like to join that community, go to patreon.com/astronomycast. Each week, I read out some of our patrons, and this week I would like to specifically thank Astrosets, Stephen Veit, Burry Gowen, Jordan Young, Kevin Lyle, Jeanette Wink, Nanoflips, Boy Andre Leisval, JF Rajotte, Andrew Poelstra, Brian Cagle, Venkatesh Chary, David Truog, TheGiantNothing, Aurora Lipper, David, Gerhard Schwarzer. I'm going to go with that. Will Hamilton, Buzz Parsec, Keko Sarif, Laura Kettleson, Robert Plasma, Les Howard, Jack Mudge, Gordon Dewis, Joe Holstein, Adam Anise Brown, Frank Tippin, and Richard Drum. Thank you all so much for everything you do.
Thanks, everyone. And we will see you all next week.
Bye-bye. And then they saved.
Then they saved.
All right. So let's see what else we have in here. Hello, Raj. It's good to be back from hiatus.
Did Raj say that on Twitch? Because Raj also said that on YouTube.
Well, he just is someone who wants to make sure we see the message.
Mission accomplished.
Yeah.
All right. Hal McKinney asks, how much of Dart's impact was absorbed by the gravitational attraction to the parent asteroid? Changing the parent asteroid's trajectory slightly as well.
So what ends up happening physics-wise is you have a space rock that has an acceleration due to the parent body. So Dimorphous is getting accelerated as it goes round and round Didymos. So then you have the spacecraft, which has its vector component that comes from its ion engines. I don't know if it was accelerating or not at that point. And then it also has gravitational acceleration both toward Didymos and towards Dimorphous that it was steered toward. The momentum is going to be caused by a transfer of its mass and its total velocity that is the result of all of these different forces acting on it. So it becomes a muddier problem where you have to take into account all those different forces to get the amount of momentum transferred and the direction of the momentum transfer.
But in theory, Dimorphous and Didymos orbit a common center of gravity.
Yes.
Kind of like if we were observing an exoplanet, detecting it with the radial velocity method.
Mm-hmm.
And so you would see Didymos moving forward and backward from our perspective, although I guess they're probably not lined up, although they probably are, because that's how they discovered Dimorphous in the first place.
Yeah. So
So
we see the movement, and we
we
also
would
can
see,
see the change in brightness
right.
from being able to see both bodies reflecting light to only being able to see them combined reflecting light.
Right, but all I'm saying is that by the two of them orbiting this common center of gravity,
Yeah.
essentially the gravity of Dimorphous is going to be yanking Didymos back and forth as if it was a exoplanet pulling its star back and forth.
Yeah.
And in theory, you could observe the spectrum of the light coming from Didymos and measure the change in orbit based on that. But that sounds way harder than just measuring how long it takes for Dimorphous to go once around.
Yeah.
Yeah.
I look forward to seeing the results from this and seeing how they get them.
Yeah. What's your gut? Do you think it's going to be greater than we anticipated, precisely what we anticipated, or surprisingly less than was anticipated?
I think based on the size of the plume that we will have accelerated it in its orbit towards the upper limits. That is my guess. So they had this range of possibilities, and I think we're going to be towards the top of how much it got accelerated.
Raj Luther asks, will NASA do another test launch on an asteroid made of different materials?
Hope so someday.
Yeah, not yet. But I mean, the follow-on mission to make next is now we've tried smashing an asteroid with an impactor. What about detonating a nuclear weapon nearby? What about painting it? What about using
that
a gravity?
One I want to try.
What about bouncing off of it with a giant air, balloon? So there have been a whole bunch of ideas proposed on how to move asteroids, and they all have different levels. What about attaching a solar sail? What about installing a railgun on and firing material off the surface of the asteroid? Like, it would be nice to know definitively which is the best way to move an asteroid.
Yeah.
Because all we know right now is hit it with a rock.
I want to paint Dactyl and see how its orbit around Ida changes. Yeah. I don't think anyone's ever going to do this, but I want them to paint Dactyl.
The paint idea is super interesting.
Yeah.
So that you then you paint it reflective, and then you get an increased pressure from the sun.
Yep.
That will change its orbit. Yeah.
It's all transfer totally worth momentum. Trying. It's awesome.
Yeah. Yorp. Man, there's no more questions. So then I'm going to rant.
Okay. Have at it, sir.
I don't see any rant. So I just did an interview with a guy named Peter Vickers. He is a philosopher of science at Exeter, I think, in the UK. Anyway, it was a fascinating conversation. He's just written a paper on the conversation about essentially future-proofed scientific concepts, things where the evidence is so overwhelming that you're not going to anticipate the theory getting overturned anytime soon. And like things like, is the sun a star?
Yes.
Right. You laugh, you giggle, but we've only believed that the sun is a star for the last couple of 100 years. That previous to that, the sun and the stars were two different things.
Yeah.
And now the evidence is overwhelming, and so you can assume that the science case for is the sun a star a settled issue, and it is future proofed. And so then what other things that maybe seem a little more controversial today are actually future-proof. The science is very settled. And I found the idea very, very interesting that we want to figure out a way to quickly learn what is the scientific consensus in any one area.
Mm-hmm.
And if you want to be lazy, just live your life by the scientific consensus. Should we live our lives by the scientific consensus?
I don't think
In
all topics are well enough defined to say that the canonical way of thinking is necessarily true.
I'm only talking about the things where they are. I'm not talking about the things where there is not a scientific consensus.
Yeah, then I'm probably okay with it.
Yeah. Right? That, like, we hop on an airplane.
So it turns out no one can really explain how airplanes fly completely. That's just one of those things that breaks. Yeah.
And that they're safe compared to driving your car to the airplane. And so the scientific consensus is that we should. But to even just say that, to just say, hey, listen, just accept the scientific consensus in all things in your life, and it's a big time saver, and you'll be fine. And I'm sure some people watching this right now are like, that's madness. Like that, the idea of just choking down whatever the scientists agree on is a recipe for disaster.
No. Why? Vaccines, people. Get vaccinated.
Sure. Yeah. Yeah. Most scientists agree that the vaccines are safe.
Yes.
So you can save all of that time and just say, what do the scientists say? They say it's probably safe.
Yeah.
The scientists' consensus is that it's safe. So just go get the vaccine. Don't think about it. Don't worry about it. Global warming.
Is real.
Scientific consensus is that it's real. That's happening. The humans are causing it. So just act accordingly. Vote accordingly. Live your life. But then there's other stuff that's presented to us as a scientific finding, but is not scientific consensus.
Right. Like, we know the universe is accelerating as it's expanding, but exactly what the blah is happening with the expansion rate?
Well, I mean, I can make it even simpler. Like, is it a good idea to take cold pool plunges? Oh,
yeah, that is one that's up for debate.
Is fasting healthier than not fasting?
Yeah.
And so you can go on to Yahoo Health. I'm not signaling anyone out specifically, and you'll see an article saying that scientists claim that fasting is healthier for you than eating 3
continuously
square meals. Right. Yeah. But that is not a scientific consensus.
Fasting. Just
sure, intermittent fasting. Yes. Yeah. You've got some scientists discussing one thing that might be interesting, but there is no scientific consensus.
Yeah.
And so you can't. And so, but then the corollary of that, corollary of that, is that if there is no scientific consensus, you can ignore it.
That makes me uncomfortable.
I know, but that's the point. Like, if there is no scientific consensus, why should you pay attention to it?
Because they're nearing the consensus in a lot of cases, and it's fun to go along for the journey.
Mm-hmm.
So,
but also you get whipsawed, right? This is how you get fasting is good for you. Fasting isn't good for you. Fasting is good for you. Fasting, fats are good for you. Fats are bad for you.
This is where following the research is a good spectator sport, because there is fairly good consensus that life forms that eat roughly 10% below the average caloric need actually live longer. or underweight by 10%. There's a 10% in there somewhere.
Yeah, but there is no scientific consensus for that. If you polled 100 biologists, you would not get 97 of them saying the science is telling us that if you starve organisms, including human beings, they are healthier longer.
I'm not saying healthier. I'm saying they live longer. That one
Sure.
they had consensus on.
I don't think you have scientific consensus on that.
Okay.
Yeah, but like, feel free to prove me wrong. But
life is short. I read an article in American Scientific. I'm going to move on with my day.
Yeah. So that can be ignored, I think.
And
just
I
safely
consider
ignore
it a spectator sport where I can choose to follow along with the same, am I going to follow a sports ball game?
But if you choose to form an opinion on an area where there is not scientific consensus, the onus is on you.
Yes.
And you say spectator sport, but it's more than spectator sport. It's active participant. So I
think it can be a spectator sport in the way people used to talk about baseball numbers and stats, where you can acknowledge there's this group of thought, there's this group of thought. I am personally rooting for these people, but these people may have it. So you can step outside of it as long as you acknowledge that there's different schools of thought in the race.
But but that's kind of like saying my car is making a funny sound, and I polled 10 mechanics, and 5 mechanics say my transmission is blown, and 5 mechanics say my motor is blown. So provide the proper course of action at this point. What should I do now?
So
5 mechanics say my transmission is gone. 5 mechanics say my motor is gone.
And you know, given the history I've had with auto mechanics, they're all wrong. And that's the thing, is you have to acknowledge it could be both are right. Both are busted. It could be the water pump and neither of their things are right.
Sure, absolutely. So, but like, what is the course of action, to use back to your analogy of it being a spectator sport? What concrete action to live my life better, such as have a working car so that I can get to work, should I take in this situation when there is no consensus on which thing to do?
So when there's absolutely no consensus, then you have to say, what are the testable things that we can do? And with a car, you can luckily run the experiment. With the universe, it's not always possible. And with biology, you have to get past your internal review board. And if there's no testable thing, unfortunately, you have to pretty much flip a coin and start in on one or the other.
So I'm
not saying it's satisfying.
No. I think the point is just like, that's a situation. Yeah, John Selfless says buy a new car, right? Like, you know, like the 5 mechanics who say it's your transmission. So you're like, so you want to go with it and order that new transmission? While the 5 mechanics about the motor, like, don't do it. You need to order the new motor. Now's the time to order your motor. And so I think that analogy holds with our situation, which is that there is no scientific consensus, and so in this case you do need a car fixed, and so you have to push the science forward. Right? You have to get a bigger survey. You have to get more mechanics to look at the problem and diagnose it. You have to come up with better scientific instruments to really figure out, is it the transmission or is it the motor?
You have to hit it with a spacecraft and see what part breaks first.
Yeah, whatever. And so I just think that the scientific consensus, done right, is your easy mode to living your life.
Yes.
And when the scientific consensus is not there, it is also your easy mode to ignore it. Because you are flipping a coin, essentially.
That I agree with. I also think it can be fun to follow along.
totally, absolutely, yeah. It's super fun to watch the mechanics and the mechanics argue about your car. But I just think that it's like what I find really interesting is just to say that like just accept the scientific consensus is an unsettling thing to hear. And because scientific consensus is seen as a pejorative, it's seen as a negative, that
Yes.
when scientists agree, it means they've given up hope, that they're phoning it in, they're all group thinking, and that is not true. They
No.
are scientists are locked in carnage, trying
Yeah.
to overturn each other's ideas, and they are no longer able to try as hard as they can to overturn the ideas. And that's what scientific consensus means.
I love this comment from QL299 over on Twitch. They write, "You wouldn't download a simulation of our universe in which you are downloading a simulation of our universe in which..."
Yeah.
He just
Yeah.
amuses me.
Yeah.
And
Yeah.
Commander Unifex is talking about certainly easier to print a car. I don't know anyone that could afford the raw materials to print a whole universe.
So so anyway, I have no answers, but
And that's
but
okay.
it's food. It's food. Yeah, it's food for thought. I think at the end of the day, nature is is the ultimate arbiter.
Yeah.
Nature will reveal the secrets of the universe,
And it does
to
not care
us,
what we think.
and it doesn't care what we think. Yeah, yeah. And I think the other thing is like if your gut tells you that the scientific consensus is wrong, if you are a skeptic, and hail the skeptics. Like the skeptics are the greatest heroes out there, as long as they do the homework.
Yes.
Right? If you do your homework, if you're a skeptic and you do your homework properly, you are a hero to me.
Yeah.
If you don't do your homework, then you're a lazy bum. Right? So, and then analogy is you climb a mountain, like you climb Mount Everest, and if someone can get almost to the top of Mount Everest, and you think you can climb higher on Mount Everest, no problem.
Yeah.
You've just first got to climb as high as they did.
Yep.
In other words, you've got to understand the material as well as they do.
What
And
always
then
gets...
you can climb the rest. And if you're unwilling to understand the information as well as they do, you are disrespecting the work that they've put in. And you are being
this
lazy.
is the key point. This is the most important thing in a lot of ways of what you've said. You have to get to the point of fully understanding what has come before. Yeah. And then you can move forward and beyond it.
Yep.
We get emails on the regular from people saying, can you please run the maths for me? I have this idea that will revolutionize astronomy and prove Einstein wrong.
Yep.
And I'm like, first of all, I don't like math that much.
Yeah,
and second of all,
why are you asking me to do it?
Yeah, if you can't work through the maths to fully understand what's come before, you can't discredit or credit what's come before.
Yeah.
You can, yeah.
Yeah.
And please don't ask me to do your math.
Yeah. So that's it. And then, like, if you're willing to, and example, if someone says, like, Einstein was wrong, and the person comes up to you and says, Einstein was wrong, and you're like, show me that you understand what Einstein was saying. He's like, no problem. And they sit down and they do all the math and they show it to you, and experts in relativity look and go, yeah, this person knows Einstein. And you're like, okay, fine. Now show me how he was wrong. And the person sits down and does some additional math and shows it to you. And again, a relativity specialist looks at it and goes, yeah, this all checks out. And you did it, skeptic. Einstein was wrong. You win. Nobel Prize for you.
Yes.
It's the being capable of demonstrating that you understand what Einstein was saying part that they are unwilling to go through. And so they have to remain, and a skeptic isn't the right word, because I feel like a skeptic is this word that deserves honor
Yeah.
And it's a noble battle to prove something wrong, as opposed to being a denier, being lazy, being anyway. This is a theme that I've sort of been mucking around with on my channel. I did an interview last week, and this interview today just really got me thinking, and I was quite excited about it.
That's
So
awesome.
I wanted to share it. So anyway, we've reached the end of our show. Was there anything else? I know I kind of. That's what you get if you don't ask questions, people. You get Fraser rants, and this is what you got today. You have only yourselves to blame.
It's true. It's true.
What's going on, Pamela? What are you working on?
So I'm going to be reaching out to all of our patrons over on CosmoQuest today, letting them know that we're going to start being more on top of using Crowdcast, actually, to be able to do our live streams out just to our patrons. We're really proud that we finally figured out how to do that. And we're going to be able to make that a patrons only benefit, to see the live recordings as opposed to the final edited pieces. Working on trying to figure out just when is SLS going. I feel like we need to have a betting pool for SLS and Starship right now.
Yeah, I like November 1st. I like it.
I really think it's going to go up Thanksgiving Day.
So, okay, I've been predicting this every week, and so far I've been 100%. But it's not hard to bet against SLS at this point. That's easy. Although I did predict weather. Yeah, I predicted each of the reasons why it didn't work. So my prediction is November 1st, when they're hoping to launch, there will be some technical issue, because introduce new bugs, taking it back to the VAB, introduce new bugs into the system, and they're going to have to work out those bugs. So the first time it'll be delayed, the second time it'll launch. So my prediction, it won't be the November 1st launch. It'll be the next window.
The next window is Thanksgiving.
Oh, then you're right.
Yeah.
And it's a holiday. That's the real reason that you're right, is that it's the holiday.
Yep.
Yes. Of course it is. Of course. All of my logic goes out the window. You're 100% right. It's another holiday. This is why it's happening. Yeah.
In addition to that, we're getting ready for CosmoQuesticon, which is going to be the weekend of October 19th. Drop on over to cosmoquest.org to get your tickets. And we're really looking forward to that. And we're doing a Let Them Sleep fundraiser in the background in hopes that we don't have to do a hangout-a-thon.
Sounds good. Awesome. All right. Well, thanks everyone for joining us today. Thank you to all the moderators. Thanks everyone on YouTube and on Twitch for watching us. But fight, not to the death. Thank you to everyone, the entire production team that helps us make this show happen every week. We really couldn't do this without you. And Pamela, thank you for bringing the brain once again, explaining the science. We will see all of you next week. Thanks, everyone.
Bye-bye.